Welcome to The Explainer. So today we're tackling a really interesting question. What if you could make an AI smarter, not by rebuilding it from scratch, but just by asking it questions in a more clever way? We're going to dive into some surprisingly simple tricks that can seriously boost an AI's performance, all without any of that expensive and time-consuming retraining. All right, let's jump right in with a bit of a puzzle. We have these AI models that are, incredibly powerful. They can write poetry, they can write code, but what do you do when one of them gets something really basic wrong? So you'd think the only option is to go back to the drawing board, right? Do a massive, costly retraining. But nope. What if I told you the answer is actually way simpler, and it all boils down to how you ask the question in the first place? To really see what I'm talking about, let's look at a clear-cut example. We're going to see a very, very capable AI get totally tripped up by something you probably learned in high school algebra. So here's the problem. It's a pretty standard equation, the kind of thing you could work out pretty easily with a pen and paper. We've asked the AI to just act like a helpful math assistant and give us the answer. And the AI's answer is 20, which is, well, it's not even in the ballpark. The correct answer is actually 83. So what gives? How can this super powerful AI fail a test that's honestly pretty simple? Okay, so we're at a fork in the road here. We have two choices. We could go down the long, super expensive path of retraining the whole model, or we could try something faster, cheaper, and frankly, a lot more elegant. We can just get smarter about how we ask. And this really shows the two roads we can go down. On one hand, sure, more training gets you better results. But that's the expensive, slow lane. But then there's this other idea, inference time scaling. Now that's just a fancy term that means you can get better results by being a bit more clever at the exact moment you ask the question. And that's the path we're taking today. All right, let's get into our first fix. And honestly, it's something your middle school math teacher probably told you 100 times. It's all about showing your work.
So remember this prompt? Super straightforward, right?
And
It got us the wrong answer.
okay, now watch this. We're just going to add 3 little words to that prompt. Explain step by step. That's it. This whole technique is called chain of thought prompting, and it is a total game changer. And boom! Just like that, everything is different. The AI is now literally walking through its own logic, step by step. It breaks down the problem, solves for X, and what do you know? It lands right on the correct answer, 83. So what's the magic here? Why does this work so well? Well, by asking it to show its work, we're basically making it slow down and think. It breaks the big problem down into smaller, bite-sized pieces, which gives it more chances to spot a mistake along the way. Plus, it starts to look a lot more like the kind of solved problems it saw in its training data. Okay, so chain of thought is awesome. It's a huge step up. But can we do even better? Can we make the results even more reliable? What if instead of just one path to the answer, we could make the AI explore a bunch of different ways to get there? To do that, we got to talk about AI creativity. So deep down, what is one of these large language models? Think of it like a super-powered autocomplete. At any given moment, it's always just trying to guess the very next word. It gives a score, a logit to every single word it knows, trying to figure out which one should come next. And here's the cool part. We can actually mess with how it makes those guesses. There's this little setting called temperature. Just think of it like a creativity dial. If you turn it down, you get really focused, predictable, kind of safe answers. But if you crank it up, well, things get a lot more interesting. Okay, so look at this. When the temperature is low, the AI is super confident. If you ask the capital of Germany is, the score for the word Berlin is so high, it's like a giant skyscraper. The AI is basically shouting, this is the only answer. But now, look what happens when we turn up that dial. See how everything flattens out? That skyscraper for Berlin is now just one building in a whole city of possibilities. Suddenly, other, less obvious words have a fighting chance. This is exactly how we get the AI to think outside the box a little. Now, obviously, you can't just have pure chaos, because that's how you get nonsense. So we need some guardrails. That's where something called top P sampling comes in. It's basically a filter that tells the AI, okay, be creative, but let's just ignore the really, really weird ideas, all right? And this is a great way to see it in action. You line up all the possible next words, from most likely to least likely. Then you just draw a line and say, we're only going to consider the words in this top group, the ones that make up, say, the first 80% of all possibilities. This little bundle of good ideas is what keeps the creativity focused and useful.
Okay, so we figured out how to make the AI explore different paths. That's cool. But how does that help us get the one single correct answer to our math problem? Well, this is where we bring it all together with our final and maybe most powerful technique.
It's called self-consistency, and the idea is actually super intuitive. It's like asking for a second opinion, and a third, and a fourth. You have the AI solve the same problem over and over again, but because we've turned up the creativity, it tries a slightly different way each time. Then you just count the votes. It's like the wisdom of the crowd, but the crowd is just the AI itself. So the playbook for this is really straightforward. 1, you start with that explain step-by-step trick. 2, you crank up the creativity dial with a higher temperature. 3, you let it run the problem a bunch of different times. And 4, you just pick the answer that shows up the most often. The majority rules. Simple as that. So what's the big takeaway from all this? It's that making AI better isn't always about building a bigger, more expensive machine. Sometimes it's just about being a smarter user. Techniques like chain of thought and self-consistency let us squeeze so much more accuracy out of the tools we already have. And this really leaves us with a wild thought to chew on. I mean, if we can teach an AI to come up with multiple opinions and then check its own work to find the best one, what's the end game here? As these techniques get more and more sophisticated, it makes you wonder, what's coming next? Thanks for joining this explainer.